Welcome back to the deep dive. We're diving into large language models, LLMs this time.
Sounds fun.
You sent us some really interesting research.
Oh, yeah.
A paper called Model Tampering Attacks Enable More Rigorous Evaluations of LLM Capabilities. And we're going to be uncovering
Title.
how these AI systems are evaluated for safety and the potential weaknesses that might be lurking there.
This paper goes right at a really key question.
Okay.
How can we accurately figure out the risks of LLMs?
Yeah.
Especially when we're talking about preventing harmful behaviors.
And the paper argues
Yeah.
that traditional evaluations they're mainly focused on the model's input and output, and they're not really giving us the whole story.
Exactly.
Correct.
It's like, just because a model won't say something harmful doesn't mean it can't. This research brings in a new concept, model tampering attacks.
Ooh, tampering.
It's a new way to really stress test LLMs.
Okay.
And it shows us some hidden vulnerabilities.
So tampering, break it down for me.
Okay, so instead of just looking at what the model says, we're going deeper. We're looking at the structure.
Okay.
We're going inside.
Interesting.
There are two main types.
Okay.
Latent space attacks. Those change the model's internal activations and weight space attacks. And those change the model's core settings.
Gotcha.
Often through fine-tuning.
So we're almost probing the AI's thoughts.
Exactly.
Not just its words.
Yeah, imagine trying to understand a human brain.
Okay.
If you just watch their behavior, you get some clues.
Right.
But if you could access their memories or see their thought patterns directly, you get a much better picture.
Yeah, that makes sense.
That's what we're doing here.
That's a good analogy.
With these attacks.
So the researchers put these attack methods to the test against two common safety strategies, unlearning and jailbreaking.
Right.
Remind me what those are again.
Sure. So unlearning, that's where you want to remove some specific unwanted knowledge from the model.
Okay.
Like teaching it to forget something harmful.
Got it.
Jailbreaking, on the other hand, is about making the model refuse to comply with harmful requests.
Okay.
Even if someone tries to force it.
So unlearning is like erasing the memory, and jailbreaking is more like resisting bad influences.
Yeah, you could think of it that way.
So what happens when you pit these strategies against the tampering?
They found some pretty interesting stuff.
Like what?
First, unlearning might not be as effective as we thought.
Oh, really?
Even with really advanced methods, you can reverse the unlearning with not much effort. Sometimes just a few steps of fine-tuning.
So that knowledge is still in there somewhere.
It's like it's lurking beneath the surface.
It's not really gone.
Yeah, more like suppressed than deleted.
Okay, so what about jailbreaking?
Well,
did those defenses hold up any better?
Not really. Every single jailbreaking method they tested was still vulnerable to model tampering. It seems like even really well-designed safety measures might not be enough if someone really wants to exploit the model.
That's unsettling.
It is.
So it seems like we need a better way to approach LLM security.
Yeah.
What other key takeaways came out of this research?
One really interesting finding was this concept of a robustness subspace.
Okay.
It seems like how a model resists different types of attacks isn't random. There are some underlying patterns.
Okay.
It's like if you imagine a landscape where the peaks and valleys represent how vulnerable the model is.
Gotcha.
The research suggests that those peaks and valleys aren't just scattered randomly.
Okay.
There's a structure to them.
So it's not about fixing each individual problem.
Right.
It's about understanding the whole landscape.
Exactly, like understanding the terrain of the model's defenses.
I like that.
This robustness subspace could be a game changer for AI safety.
How so?
If we can figure out how to map this terrain, we can develop much more effective security.
That makes sense.
Like a targeted approach.
So it sounds like this research is a bit of a wake-up call.
It is.
Our current methods for figuring out and dealing with LLM risks might be giving us a false sense of security.
Yeah, this research shows just how important it is to have really rigorous and realistic testing, especially for those open weight models that anyone can access and change.
Let's dig into that a little bit more.
Okay.
Why are open weight models particularly vulnerable?
So in an open weight model, anyone can see how it works.
Okay.
The weights, they're all public. This is great for research and collaboration.
Yeah.
But it also means anyone could mess with the model after it's released.
So they could get in there and change things.
They could undo safety measures, even make it do harmful things.
Wow, that's scary.
It's like leaving the control panel of a powerful machine wide open.
Yeah.
And remember, this research shows us that unlearned knowledge can be brought back pretty easily.
So it's really not gone.
Not really.
So is unlearning really a good way to keep things safe?
That's a really good question.
Yeah.
And it's something that developers and policymakers and regulators all need to think about.
Yeah, it really challenges what we thought we knew about LLM safety.
It does.
It seems like we need more than one approach here.
Absolutely.
Tamper-resistant techniques, stricter regulations, and a deeper understanding of how to evaluate and reduce the risks of these really powerful systems.
We need all of that.
This paper gives us a really good roadmap.
It does.
It's not just pointing out problems.
Nope.
It's offering a path forward for safer and more robust AI development.
Exactly. And the implications go way beyond just the technical stuff.
In what way?
This research asks some really big questions about how we govern these technologies and how we make sure they're used ethically and responsibly.
So we've got a lot to unpack here.
We do.
Let's dive into some of the specific findings in this research.
Okay.
We talked about unlearning and jailbreaking. But how did they actually test these safety strategies? What kind of attacks did they use?
Well, they used a whole bunch of different attacks. 11 in total.
Wow.
5 of them were input space attacks.
Okay.
Those are the traditional methods. And 6 were those new model tampering attacks.
Okay, and to really get into the details, they focused on potentially dangerous knowledge about dual-use biology.
Right.
Dual-use biology. What does that mean?
So dual-use biology is research and technologies that could be used for good or bad.
Okay.
Like research on viruses.
Okay.
That's essential for vaccines.
Right.
But it could also be misused to create bioweapons.
That makes sense.
So they trained these models on information that could be dangerous.
Yeah.
And then they try to unlearn that knowledge.
So to make it safe.
Exactly. They wanted to see if different unlearning methods could get rid of that dangerous information, but still keep the model useful overall.
Yeah, what happened?
Well, it wasn't as straightforward as you'd hope. Even the best unlearning methods could be undone, sometimes with just a few little tweaks.
Wow. So even after they tried to unlearn it, it wasn't really gone.
It seems like it's much harder to really erase something from an AI's memory.
Than we thought.
That's
a little scary.
Yeah, it is.
Okay, so you mentioned these model tampering attacks that go after the model's inner workings. Can you explain what latent space and wait space attacks are?
Sure. Think of an LLM like a giant web.
Okay.
Each node is a concept, and the connections show how they're related.
So like a map of knowledge.
Yeah.
Where the nodes are concepts and the connections are like the relationships.
Exactly.
Okay, I can see that.
The latent space is that hidden network of connections.
Okay.
It's the underlying structure that controls how the model processes information and creates outputs.
So it's like the AI's thought process, the way it connects the dots?
That's a great way to put it. A latent space attack tries to mess with that thought process by changing those connections.
So not changing the information, but how it all fits together.
Exactly.
And then a wait space attack.
Okay, so what's that?
The weights control how strong those connections are.
Okay.
Like speed limits on a highway, controlling how fast information flows.
So if you change the weights, you're changing the speed limits.
Got it.
And that changes how the model processes information.
Precisely.
This is starting to sound very Matrix-like.
It is a bit, isn't it?
We're messing with the AI's brain.
Yeah.
And potentially change how it thinks and acts.
Right.
This is a powerful capability.
It is.
And it raises some big ethical questions.
Absolutely. And that's what we'll be looking at next.
I'm ready to dive deeper.
Let's do it.
Stay tuned, listeners. We're going to be exploring the potential dangers of model tampering.
Some scary stuff.
And what we can do to protect ourselves from these threats. These attacks can be used for some really bad stuff.
Okay, like what? What are some real-world scenarios where they could cause harm?
Okay, so imagine someone with bad intentions gets access to an open-weight model being used in healthcare.
So we're talking about an AI system that's making important medical decisions.
Exactly. And with these model tampering attacks, they could make the model misdiagnose certain conditions.
So the AI looks like it's working fine, but it's actually making dangerous mistakes.
Yeah, because someone messed with its code.
That's scary.
And the worst part is these changes can be really subtle.
You wouldn't even know.
Hard to detect.
It's like a poison, slowly corrupting the system.
That's a good way to put it.
Are there other scenarios where these attacks could be used?
Definitely. One big concern is misinformation.
Okay.
Think about an attacker targeting a language model used for news or social media posts.
So they could create fake news that looks totally real.
Exactly. By tweaking the model, they could add bias or even lies.
And with LLMs getting so good,
Right.
this could be impossible to detect.
It's a big threat
Yeah.
to how we trust information.
So we need better safeguards.
We do.
What can we do to protect ourselves?
One thing that's promising is tamper-resistant techniques.
Okay, so like a security system for the AI.
Right. Make it harder to hack.
And how do those work?
Some use cryptography to protect the model.
Okay.
Others make the training algorithms more resilient.
So it's harder to mess with them.
Exactly. And these techniques are always getting better.
That's good.
Researchers are trying to stay ahead of the bad guys.
But what if someone gets past those defenses?
Well, then you need good detection systems.
Okay.
These are designed to watch the model's behavior and flag anything weird.
So they're like watchdogs,
Yeah.
looking for signs of trouble.
They can spot patterns that show tampering,
Interesting.
like if the accuracy suddenly drops or there are unexpected outputs.
Like a lie detector for the AI?
Exactly.
So what happens if it detects tampering?
The model can be quarantined
Shut it down.
to prevent more harm.
So it's contained.
Right, like a digital quarantine.
And then?
You need to have backups.
So you can restore it.
Right, get it back to a safe state.
So we're using what we've learned from cybersecurity?
We are. It's all about protecting systems from unauthorized access and manipulation.
But AI is more complex.
It is.
Because it learns and adapts.
Yeah, that does make it tricky.
But I'm sure we can figure it out
I think so too.
by combining cybersecurity with AI-specific safeguards.
Right.
We can make AI both powerful and safe.
That's the goal.
Okay, before we move on, I
Yeah.
want to go back to that robustness subspace idea.
Okay.
Can you explain that a bit more? Why is it so important?
Remember we talked about that landscape where peaks and valleys show vulnerability?
Yeah.
This research says that landscape isn't random.
Hmm.
There's a pattern.
Okay.
So a model's ability to resist one attack
Mm-hmm.
might be connected to its ability to resist others.
So it's not just fixing individual problems.
Right.
It's more about,
Understanding the connections.
yeah, the underlying connections between the strengths and weaknesses.
Exactly.
Okay, I see.
And if we can understand this robustness subspace,
Yeah.
we can create security measures that are much more effective.
That's cool.
Like instead of just playing whack-a-mole,
Right.
we can target those underlying patterns.
Make it strong overall.
Exactly. That's the potential here.
Okay, so it's about being more proactive
Right.
instead of just reacting to problems.
We want to understand AI risks and how to mitigate them.
This research seems like a big step towards that.
It is. It makes us face these challenges head on.
Okay, now let's talk about those different approaches.
Okay.
Unlearning and jailbreaking.
Right.
Can you explain those a bit more?
So unlearning is kind of like giving the AI amnesia.
Okay.
We want to remove specific knowledge.
But not everything.
Right. Just the bad stuff.
Okay.
It's like teaching the AI to forget something. There are different techniques,
Yeah.
but they all involve adjusting how the model learns.
So how well does it work?
Well, as we said before, it's not perfect.
Right.
Even the best methods can be undone.
So the knowledge is still there,
Yeah, it's like it's hiding.
waiting to come back.
Sort of.
Okay, what about jailbreaking? How is that different?
Jailbreaking is more about teaching the AI to resist bad requests.
Okay.
It's about giving it ethics and responsibility.
Interesting.
So it refuses to do bad things.
Even when someone tries to force it.
Exactly.
So like a moral compass.
Yeah, we want the AI to do the right thing.
Even under pressure.
Right.
Did they find any methods that were really good at creating this ethical AI?
Sadly, no.
Oh.
They tried a lot of different defenses, but they were all vulnerable to those model tampering attacks.
So even when we try our best
tough.
to build in those safeguards,
It might not be enough.
if someone really wants to exploit the model,
Yeah, AI safety is a constant battle
we need to be ready.
and always coming up with new strategies.
This is complicated stuff.
It is.
How did they even test all of this?
It was a lot of work.
Yeah.
They used a mix of old and new attack methods, focusing on those model tampering attacks,
Yeah.
the ones that go after the model's insides.
Right.
What they found was that these attacks
Mm-hmm.
were much better at finding vulnerabilities.
Than the traditional methods.
Yeah, they were really digging deep.
To find the AI's weaknesses.
And the results were pretty surprising.
Yeah.
They showed just how fragile our current safety methods are.
So we need better solutions.
We do.
It seems like we're just starting to understand LLM security.
Yeah, we're still early on.
But this research is a good foundation.
It is.
It reminds us that AI safety isn't just a technical problem.
Right.
It affects society.
It does.
It changes how we develop and use and govern these technologies.
Exactly.
This is a conversation everyone needs to be part of.
Absolutely.
Not just the experts.
We all need to be aware of the risks.
And work towards responsible AI development.
I agree.
Okay, you've given us a lot to think about.
Good.
But before we wrap up, I want to go back to that finding that model tampering can predict how vulnerable a model might be
Right.
to new attacks.
That was a cool finding.
Yeah.
One of the most surprising parts of the study.
Okay.
They found that certain model tampering attacks,
Okay.
especially the ones on the embedding space and latent space.
Okay. Remind me what those are again?
Okay, so the embedding space, that's where the model represents words as numbers.
Okay.
It's like a dictionary for the AI.
Which translates our language.
Right, so the AI can understand.
And the latent space.
That's where it figures out the relationships between those words.
So it's more abstract.
It is. It's about the meaning.
The deeper meaning.
Exactly.
So the embedding space is like the raw data.
Yeah.
And the latent space is where the AI understands it.
You got it.
Okay.
And what they found is that by attacking these spaces, you're basically testing how well the AI understands language.
How it makes sense of the world.
Right. And the cool thing is how well those attacks work can predict how well the model will handle new attacks.
Ones it's never seen before.
Exactly.
It's like finding a master key
Yeah.
to unlock all the vulnerabilities.
It shows that different types of attacks are connected.
They have shared weaknesses.
Exactly.
So we need to understand those patterns.
That's the key to building really secure AI systems.
It's about seeing the bigger picture.
Right. Not just focusing on individual problems.
We need to understand how the AI's defenses work.
Exactly.
Okay, we've covered a lot today.
We have.
From the technical details of these attacks to the bigger implications for AI safety.
It's a big topic.
Yeah. But before we wrap up, is there anything else you want to add?
I think the biggest takeaway is that we're all responsible for AI safety.
Okay.
It's not just the researchers and developers.
We all have a role to play.
Yeah, we need to be aware of the risks.
And push for responsible AI development.
I agree.
So it's about being aware and responsible. And making sure these technologies are used ethically.
Right. For the benefit of everyone.
You've given us a lot to think about.
I'm glad.
But before we sign off,
Okay.
I have one last question.
Shoot.
We've talked about how model tampering can bring back harmful capabilities.
Right. Even after unlearning.
But does that knowledge ever really disappear?
That's the big question.
Yeah.
And it's something researchers are still working on.
It's almost philosophical.
It is.
If an AI learns something, can it ever truly forget?
That's a tough one.
Yeah.
It have big implications for the future of AI.
I'm sure we'll figure it out.
I think so too.
With more research and a focus on responsible development.
Right. We can make sure these technologies are used safely and ethically.
That's the future I want to see.
Me too.
Thanks for joining us on the deep dive. This is really fascinating stuff. So to recap, we've learned that the old way of evaluating LLM safety might not be enough.
Yeah, it's not the whole picture.
Model tampering attacks seem like a better way to test these systems.
Right. They really expose those vulnerabilities.
And we talked about some solutions, tamper-resistant techniques, those detection systems.
Those are promising areas.
But before we wrap up, I want to go back to something we haven't fully explored yet.
Okay.
You mentioned that the researchers actually released a set of 64 models that are trained on this dual-use biology stuff.
That's right.
And they're encouraging other researchers to use them.
They want people to dig in.
So they specifically chose dual-use biology because of the potential for good and bad.
It's a high-stakes area.
Yeah, big implications.
By making these models public, they hope to speed up research on AI safety.
Get more people involved.
And encourage collaboration.
So it's like they're saying, here are some tools, here are some problems, let's work together.
Exactly. AI safety is a big challenge.
Too big for one person or one group.
We need everyone to find solutions.
By focusing on dual-use biology, they're also highlighting the real-world risks.
Not just hypothetical stuff. This is about technologies that could impact human health and safety.
This is serious stuff.
It is.
So AI safety is not just some abstract problem.
Right. It has real-world consequences.
We need to be proactive.
Absolutely.
Before it's too late.
We need to make sure these technologies are used for good.
And not for harm.
That's the goal.
Okay, before we say goodbye,
Yeah.
I want to leave our listeners with a final thought.
Okay.
We talked about how model tampering can bring back those harmful capabilities.
Even after unlearning.
But does that knowledge ever really go away?
That's a deep question.
Or is it just hiding, waiting to be unlocked?
It makes you wonder how AI really works.
Does it truly forget?
Or is it storing information in a way we don't understand yet?
It's a question that gets at the nature of memory and knowledge.
Even consciousness.
In the context of AI.
It's fascinating.
As we learn more about AI,
Yeah.
we're not just facing technical challenges.
It's bigger than that.
We're facing these big questions about intelligence.
About our relationship with these powerful technologies.
It's a future with a lot of potential.
And some risks.
It's up to all of us to make sure AI is used for good.
I agree.
Thanks for joining us on The Deep Dive.